So in part C, we're going to examine type 1 and type 2 error. So imagine that you've invented a drug that you believe could prevent Alzheimer's syndrome. People take this drug, they're less likely to develop Alzheimer's. You've done a number of preliminary trials, and now you want to test it experimentally to see whether it's effective in humans. So here are your hypotheses. Your null hypothesis: individuals who take the drug will have no more years of brain health than individuals in general. And your research hypothesis: individuals who take the trial drug will have more years of brain health than individuals in general. We can see that this is a one-tailed high test. Picture that distribution with a shaded area in the upper tail. So now you ask yourself, how sure do you want to be of your conclusion? Will you set significance levels at 0.05? You want to be 5% chance of getting the right conclusion, 1% chance, less than that? So now we weigh the risks. And the first thing we'll consider is type 1 error. Remember, when we think about this, that statistics are just probabilities, never truths. We can never know every single possible outcome. So there's always a chance that we'll draw the wrong conclusion. So we have to weigh out the consequences of drawing a false conclusion. So the first type of error we could make is called a type 1 error, and that's a false positive. In other words, we draw a conclusion that the drug is effective in preventing Alzheimer's when in fact it is ineffective. So what are the consequences of this? Of making a drug, and you draw the conclusion, you reject the null hypothesis, and you think, yes, it's effective, but it's not. So what are the consequences? Well, let's think about it. The drug presumably will be distributed. The manufacturer will start to sell the drug, and lots of people will take it. And those people that take it will believe that it will prevent Alzheimer's. And so because they believe this, they believe they are not going to get Alzheimer's because of this drug, maybe they'll neglect other things that are known to reduce Alzheimer's, like avoiding alcohol, like exercise for the brain, like generally maintaining good health, like maintaining social relationships. So they skip all those things because they have this drug. In that case, more people, if the drug doesn't work, more people might develop Alzheimer's than otherwise would. So that's a possible consequence. So we're just thinking here. Another consequence might be, well, the drug company will make a lot of money selling a drug that doesn't work. Maybe the company will be happy. They have a short-term profit. But in the long run, when it's discovered that the drug doesn't work, its reputation may be harmed. So type 2 error is a false negative, drawing a conclusion that the drug is not effective in preventing Alzheimer's when in fact it was effective. So the consequences of type 2 error, that is, you have a drug that worked, but you incorrectly drew the conclusion that it didn't work, the drug won't be distributed. People will continue to develop Alzheimer's who could have avoided it if the researchers had not made this error. And the drug company won't develop the drug and won't earn money. And maybe even research on this direction, like research about the general mechanisms under which this drug was working, maybe that would stop. And so there would be long-term neglect of an important preventive treatment. So which do you think is most serious in this case, type 1 error or type 2 error? If you were the researcher, which would you most want to avoid? Would you rather make a mistake of selling a drug that doesn't work or not selling a drug that could have worked? Well, you'd rather get it right, of course, but you have to weigh out these risks. So one way that we do that is we adjust significance levels. So lower significance levels, like 0.01 or lower, reduce the likelihood of type 1 error. Less likely to sell a drug that doesn't work if you have lower significance levels. Higher significance levels, like 0.05, reduce likelihood of type 2 error. So which error do you want to go on? We typically, in medical things like this, typically go with lower significance levels so that we're not going to be selling drugs that don't work. But it depends on the case. It depends on the situation. It's something the researcher has to weigh out, and that's you. in our work. So let's look at this a little more. This can be a complicated idea. So a statistical test is an exercise in probabilities, but they are real-life consequences. We all seek to know reality, but we can only get at likelihoods or probabilities. What we measure or perceive may represent reality. In fact, 95% chance if we set our 0.05 significance level. Or it may not represent reality, 5% chance. So in terms of the example we just gave, this drug, there is a reality out there. Either the drug works or it doesn't work. We don't know. And we're measuring something. We're looking at whether we think it works or doesn't work. And it's possible that our measurement or perception will be accurate and it will represent reality, and that's a good thing. And so that means that if it's true, the drug works, and we conclude that it's true, then it's correct, we're happy. But if we conclude that it's true, the drug works, and in fact it doesn't work, then we have that type 1 error. So we could also make a type 2 error. It could be that the drug doesn't work in reality. The drug doesn't work. That's the reality. And that our test shows that it doesn't work. So then we have an alignment. Our test accurately represents reality. We're correct. That's what we want. Or we could conclude that it doesn't work, but in fact it does work. And that would be our type 2 error. So let's consider these additional examples. You have a treatment that's promising as a treatment for long-term alcohol addiction. Which would have more serious consequences? Type 1, offering this treatment for long-term alcohol addiction, but it doesn't work. You concluded that it worked, but you were wrong. Or type 2 error, concluding that your treatment doesn't work when in fact it would have worked as a treatment. Which would you take more seriously? I think the consequences of having a treatment that would have worked, but concluding that it doesn't work, so you just give it up, maybe that would be more serious. Because offering a treatment that in fact doesn't work it might be better to err on the side of offering something even if it's not as effective as you wanted than not offering it at all when it might be effective. Maybe, but that's up to the researcher. The second example, you are a juror in a trial of a man accused of murder. Which would have more serious consequences, type 1 or type 2? So in type 1 error, you find the man guilty, but he's not guilty. False positive. Send him to jail for life, but he's not guilty. Or type 2 error. Finding that he's not guilty, but in actuality, in reality, he is guilty. Which would be worse? In our country, our premise, our ideal, is that we would rather let a man go free who's guilty than put a man in jail who's actually not guilty. It's not always the way it is in practice, but that's the ethic, that's the ideal of our system. And now getting into a couple of your examples, and I'm not going to give my opinion because this is for the individual researchers to do. You're interested in whether active listening practices improve outcomes for people seeking therapy for the first time. This is similar to one of the studies someone in our class is doing. Which would have more serious consequences, type 1 or type 2 error? So concluding that the active listening practices help when in fact they don't help? Or would it be worse to conclude it would be best to have your conclusions be correct, but in the event that they're not correct, which type of error would be better? Type 1, concluding that the treatment works, the practices work when they don't, or type 2, concluding that they don't work when in fact they would have helped. And the last example, you hypothesize that women who go through a canal da ceremony have stronger self-respect as women, for themselves as women. All right, which would have more serious consequences. Type 1 error, concluding that the canal da ceremony works to improve women's self-respect, when in fact it doesn't. You're wrong. You draw the wrong conclusion. Or type 2 error, concluding that the canal da ceremony doesn't generate stronger self-respect, when in fact it does. So that's for the researchers to think about. So at this time, I will invite you to take the next practice quiz, and hopefully you'll make sense of this a little more by working out some of these problems.